Hello viewers, welcome back to my channel Experience Physics. So this class we are going to discuss about the origin of resistivity. Not only resistivity, origin of resistance and resistivity. First we will see the resistance, where it started, how it arrived, then the resistivity, right? There is a small difference between resistance and resistivity, we will discuss, right? So the origin of resistance is this equation, E by M into tau. This is the origin of resistance as well as resistivity. This is nothing but drift velocity. So this is the expression of drift velocity of electrons. I am having one conductor and I am connecting this conductor with a battery. This voltage is V and length of the conductor is L. V by L is giving me E, electric field. Then the free electrons are pulled by this electric field, because E and E will give us the force, Coulomb's force, right? So any velocity will have the format of acceleration multiplied by time. This is force. Force by mass is acceleration. Time, this is relaxation time, average relaxation time, right? Force by mass is acceleration, acceleration time, this is the velocity, this is drift velocity. For this topic, drift velocity, we have made a separate video, we have discussed in length this drift velocity, how the electrons are moving upon the application of this electric field. In fact, the voltage, once the voltage is connected to the circuit, electric field is established. This electric field pull all the electrons towards the positive terminal and the current is starts to flow, right? So the next video we have solved some numericals, few problems on the drift velocity and the mobility of electrons and the current density, right? If you have not watched those two videos, you please go and watch them. The respective links are given in the description, right? Anyhow, let us have a quick recap on this drift velocity, because this is the origin of resistance and resistivity, right? Drift velocity, the equation we wrote it as Vd is equal to EE by M into tau. Only the magnitude I have written, right? If you write it in vector form, you can make a bar over it and E over it, then the minus sign will come. Only the scalar value I have written, drift velocity, right? So V is responsible for the movement of electron. In fact, E, but E is obtained by applying the voltage. Voltage by length, I am getting the electric field, right? So I want to have a relationship between voltage and these things, right? Before that, let me write, find what is I. This is also we have discussed in the previous video. Equation for I. I is equal to Q by T, Q NE by T, quantization of charge. This N is equal to N into volume and E by T, right? This is N is free electron density, the total number of electrons per volume, per meter cube. So N is the total number of electrons inside the material, irrespective of the volume, right? So this is free electron density, this is number of electrons per meter cube, right? So N into volume, I will write it as A into L. This is the length of the conductor and this will be the cross-sectional area, volume. Then E by T. This L by T is nothing but meter per second. Drift velocity, its unit is meter per second. So N E N A V D. E N A L by T is V D, equation for current. Then again I will replace the V D with our original equation, the first equation, right? I is equal to E N A E by M tau and N K. Before that, let me again right? What is E? Capital letter E. Voltage by L. Voltage by L. E N A E V by M into L. Tau. Yes. E is replaced by V by L. Then I simplify it. N E into E square. Let me write tau here. This is M. This is A by L. Then V. Yes. N E square tau by M A by L into V. Cross multiply it to get the ratio V by I. To get the ratio V by I. This is M over N E square tau L by A. M mass of electron, N free electron density, number of electrons per meter cube. N is free electron density number of electrons per volume, per unit volume. So this is also constant for a given material. E charge, tau relaxation time. If we keep the temperature constant, relaxation time will also be a constant. So all these are constant. If you keep the temperature constant, all these are constant. Mass, free electron density, charge, tau. Right. Only the variables are dimensions, length of the conductor and the cross-sectional area. So this is written as rho. All these constants are made as a single constant, rho. Then L, then A, this V by I, this ratio from Ohm's law, we will write it as resistance, right? R is equal to rho L by A, right? So the origin of resistance is the drift velocity and the movement of electrons, right? R is equal to rho L by A, the unit is Ohm. Now let us define what is resistance, right? This is the expression for resistance. Let us define what is resistance. Resistance is the opposition offered by the opposition offered by any material to the flow of electric current. This is the definition for it. The opposition offered by any material to the flow of electric current. Look at this equation. R is equal to rho L by A. These are dimensions. Rho M over N E square tau. M mass, N free electron density, E charge, tau is also constant, mass constant, E constant. Only the N can change material to material. The N can only change material to material. So N is responsible for the value of resistance, isn't it? If N varies, rho will vary. If rho varies, R will vary. So N is responsible. If you have more free electrons, that is free electron density, it will be a good conductor. It will be a good conductor because if N is more, R will be less, I will be more current, right? Good conductor. If N is less, it's a bad conductor or simply insulator, right? So there is nothing available inside the material except the free electrons. If free electrons are more, good conductor. If free electrons are less, bad conductor. That's all, right? So opposition means there is nothing available inside the material to oppose the flow of electric current. That is not the meaning. You can't assume that a large quantity of current is coming through the electric circuit and something is available inside the material to oppose the flow of electric current. No, no, no. The current is always constant in the entire circuit. It is because of the free electron density. It depends on the material, right? Why it is varying? It depends on the atomic lattice, right? Material to material, the structure is different. So free electrons are also different, the number of free electrons, right? So its unit is R is equal to rho L by A. The unit is ohm. Unit of resistance is, so it's one of the important property of electricity. R is equal to rho L by A. Then L and A are dimension quantities. L, make it as 1 meter, A 1 meter square. Make L and A one value, that is 1 meter length of the conductor I have chosen, 1 meter square area I have chosen. My area of cross section is 1 meter square, the length is also 1 meter, right? Then R will be equal to rho. If you take one conductor such that its values are 1 and 1, R is equal to rho. So this rho is known as resistivity. Rho is resistivity or specific resistance. R is equal to rho. When you keep L and A as 1 and 1, this rho is known as resistivity or specific resistance. What is the difference between resistance and resistivity? Resistivity doesn't have the dimensions. So for any material, this value is constant because dimensions are not included. Once the resistivity is known, you can easily find the value of resistance by multiplying it with length and area, right? If you know the dimensions, you can find for your conductor, the length of the conductor, area of cross section, you can easily measure. Then you can easily find the resistance. So there is the advantage of having resistivity. For copper, it has one value. For aluminum, it has a different value, right? So this is fixed. These values can be obtained from the data sheet. Their ready-made values are available, the resistivity, the experimental values, right? What is the unit of resistivity? R ohm, area meter square, ohm meter squared upon meter, right? If you cross multiply ohm meter square by meter, keep rho the right hand side, R into A by L, R into A by L, right? So ohm meter. The unit of resistivity is specific resistance. Unit is ohm meter, right? Resistance ohm, resistivity ohm meter, right? So this is the origin of resistance as well as resistivity. Let us solve few examples in this topic. A copper wire of cross-sectional area 2 millimeter square carries a current of 5 amperes. The resistivity of copper is 1.7 into 10 to the power of minus 8 ohm meter. The electric field in the copper wire will be E is asked. Cross-sectional area is given 2 millimeter square, carries a current of 5 ampere. If the resistivity of copper is 1.7 into 10 to the power of minus 8 ohm meter, electric field in the copper wire will be what, right? IA are given, right? I by A, there is one formula, current density, right? Current density, already we have seen it in a separate video under the topic drift velocity, right? So J is equal to sigma E. Sigma and rho are having one relationship. Sigma is equal to 1 by rho. Sigma is equal, this is resistivity, this is conductivity. Conductivity is given here. Resistivity, it is 1 by rho is equal to sigma, right? So J is equal to I by A, current ampere per millimeter square. J is equal to I by A, rho is equal to, sigma is equal to 1 by rho E. From here I will write E is equal to rho I by E. So let us substitute the values directly. E is equal to rho value 1.7 into 10 to the power minus 8. Then I is equal to 5 ampere divided by area 2 millimeter square, make it as meter square, 2 into 10 to the power minus 6. This will be 8.5 into minus 6. This will be minus 2 divided by 2. 8 by 5 by 2, 4.25 into 10 to the power minus 2. E, the unit is volts per meter. So this is the value 4.25. 4.25 10 to the power minus 2. Yes, option B. A uniform metallic wire carries a current 2 amperes. When 3.4 voltage battery is connected across it, the mass of the wire, not mass of electron, mass of the wire 8.92 times 10 to the power minus 3 kg. Density is 8.92 10 to the power 3 kg per meter cube. And resistivity is 1.7 times 10 power minus 8 ohm meter. The length of the wire is what? So we have the formula R is equal to rho L by A. Rho is given. Length of the wire is in question. R is also available. V by I. Once area of cross section is found, we can find the value of length, right? For area, we have some other quantities, mass and density, right? So mass and density will give volume, right? Mass by density. So V is equal to, from volume we have to relate the area. Volume we have to relate the area. So volume is equal to area into length of the conductor. AL is equal to, yes. So from here we can write what is A. M upon DL. M upon DL. Let us put here. R is equal to rho L by, instead of A, I will write M upon DL. This will be rho into DL will go up, DL square by M. R is equal to V by I from Ohm's law. So V by I 3.4 by 2, rho value is 1.7 into 10 to the power minus 8. Density is 8.92 into 10 to the power 3 into L square divided by mass 8.92 into 10 to the power minus 3. Yes. Okay. this 3.4 by 2 is 1.7. This 8.92 and 8.92 can be removed. Minus 3 will become plus 3, 6. 8 minus 6 is minus 2. So this is 1.7 into 10 power minus 2. Minus 3 is, here it is 6. Yes, 1.7 into 10 to the power minus 2 into L square. So L square is equal to 1.7, 1.7 we can remove. This is 1. 10 power minus 2 L square is equal to E. So L square is equal to 1 by 10 power minus 2. If you take it 10 square, the L is equal to 10 meter. Yes, L is equal to 6.8, 6.8 10 meter. Option B. We need wall area R is equal to rho L by A. Area directly it is not available. From volume we are obtaining. Volume is also not available. Mass and density. On increasing the temperature of a conductor, its resistance increases. Temperature of the conductor is increased, resistance increase. Why? Because relaxation time increases, mass of electron increases, electron density decreases, relaxation time decreases. Mass of electron is constant. This will not be the answer. Electron density n value. For the material it is going to be constant. So B and C are wrong answers. Only thing is the relaxation time. Whether it is increasing or decreasing, we have to find. Temperature. If temperature is increased, thermal energy will be increased. If thermal energy is increased, kinetic energy will be increased. When kinetic energy is increased, collision between the electron and positive ion will increase. That means the collision will happen quickly. Immediately the collision, because the kinetic energy fast, electrons are moving very fast because of the kinetic energy. So immediately they will encounter with the positive ions, the collision will happen quickly. So tau will decrease. Tau is the average time interval between two successive collisions. This is the definition we have seen in the topic drift velocity. Relaxation time is the average time interval between the two successive collisions. Right? When electron comes, first collision, second collision. This is tau 1, this is tau 2. The average value will be tau. Quickly it will collide with the positive ions quickly because of the more kinetic energy. Kinetic energy is obtained from the thermal energy because you are increasing the temperature. So relaxation time decreases. Answer option D. The electric resistance of certain wire of iron is R. If its length and radius are both doubled, length and radius are doubled, what will happen? 4 options are given. The resistance will be doubled and the specific resistance will be off. The new resistance R dash will be doubled. Specific resistance, rho value, specific resistance or resistivity. the resistance will be halved and the specific resistance will remain unchanged. The resistance will be halved and the specific resistance will be doubled. The resistance and the specific resistance both will remain unchanged. Right? So specific resistance will always be constant, because for any given material, rho value is always constant. Rho is equal to m upon n e square tau. Unless otherwise we change the temperature, this is going to be constant. M, n, e, tau, everything is constant, right? So specific resistance will be halved, wrong answer. Specific resistance will be doubled, wrong answer, right? So only B and D are going to be the right answer, right? The resistance will be halved here. The resistance and specific both will remain unchanged. So they are saying in the option D, the resistance is also unchanged. You are changing the dimension, length and radius are going to be doubled. Definitely the resistance will change, right? So here in option D, the resistance is unchanged. So this is also not the correct answer. Option B is the right answer. So this is, I arrived this answer by elimination technique. I have eliminated the wrong answer and I have ended the right answer. Let us see the proof. How the resistance will be halved. Specific resistance will remain unchanged. Already we have seen it. This is also, it never changes for any given material. The resistance will be halved if you double the length and radius. If its length and radius are both are doubled, right? R is equal to rho L by A. R dash is equal to rho L dash by A dash. New values. Rho is constant. So L dash is equal to 2L. You have doubled it. Area is equal to here pi r square. Here A dash is equal to pi into 2r square. That means 4 pi r square. 4r square, yes. Then this is R is equal to rho L by A. Let me put here R dash is equal to rho. Instead of L dash, I am writing 2L. A dash 4 pi r square. So 2 and 4 are giving me this value, rho L divided by 2 pi r square. This is R dash. This rho L by pi r square. This area is equal to pi r square, right? So instead of pi r square, I can write A, rho L by A. A is equal to pi r square, right? This is 2A, in fact, yes, R dash. So the new value is of rho L by A, rho L by 2A, right? So resistance will be off. R dash is equal to rho L by 2A. So this is the proof. A wire of a certain material is stretched slowly by 10%, then its new resistance and specific resistance become respectively. R value slowly stretched slowly by 10%. 10% you are increasing. Length. The length of the material is, the new value R dash is equal to what? That is the question. If the length is stretched 10%, right? So I have this material L, then the new material is stretched 10% more than the previous one. If it is 100%, this will be 110%. If it is L, this will be 1.1 L. If it is 100%, it is 110%. So 110 means 1.1 L, right? So what is the value of the new value R dash? So dimensions are changing. So definitely there will be a change in the resistance value. Let us see it. Right? please remember, you are stretching the material. You are not adding any new material to it. You are not jointly making any you are not mixing any material, right? Already available, the volume is going to be changed. When the length increases, the cross-sectional area will decrease to keep the volume constant. So when you stretch the conductor, the volume will be constant. So if you increase the length, what will happen? If you increase the length of the wire, the cross-sectional area will be thinner. The diameter will become less, right? So cross-sectional area is going to be less. So this will be a cross-sectional area. This is A dash. A dash is going to be decreased. Why? Length is increased. Length is increased. A dash, new area is going to be decreased, right? So how much it will decrease? To keep the volume constant, volume is equal to A into L. Volume is, in both the cases, volume is constant, right? So I want volume constant. If length is increased, the A dash will decrease. This is the new value. A by 1.1 is A dash. So this 1.1 and 1.1 will get cancelled. So I will get V is equal to LA. V is equal to AL. Right? So if length is, you keep this point in your mind, if length is increased by one factor, the same amount of factor, the area will decrease. Right? Then only you will have both the volume constant. Right? So you are not adding any new material to it, please remember. Right? So the new area is A by 1.1. Right? So R is equal to rho L by A. R dash is equal to rho L dash by A dash, which is equal to 1.1 L divided by A by 1.1. A by 1.1. This is A dash. New area. 1.1 will go up. This will be 1.21 L by A. Rho L by A is R. So 1.21 R. R dash is equal to 1.21 R. The resistance value is now 1.21 times more than the resistance, right? Two questions are asked, right? Certain material stretched slowly, then its near resistance and specific resistance. Specific resistance won't change, it is constant, same. So option A is the correct answer. Both remain same, wrong. 1.1, this is also wrong, right? Logically, you can answer it without making any calculation. This is changing. Rho can't change. Rho can't change. Both remain same. Resistance will change. They can't be the same. So only option is A. A material B has twice the specific resistance than that of A. The wire made up of B has twice the diameter of wire made up of A. Then for the two wires to have same resistance, the ratio LB upon LA of their respective length must be just material A and B. This is material A, material B. Twice the specific resistance than that of A. If it is rho, then it has 2 rho, different material. The wire made up of B has twice the diameter of made of A, twice the diameter of a wire made of A. If it is D, then this will be 2D diameter. Then for the two wires to have same resistance, R is same. The ratio LB by LA, length as the ratio of length is what? This ratio is in question. So D is equal to 2R I can write in terms of radius. So this will be 2D is equal to 2 into 2R, this is 4R. 2D is equal to 4R. So R is equal to rho, this is the length is LA upon area pi into 2R square. So this is rho LA upon 4 pi R square, right? LA upon 4 pi R square. Here R is equal to rho value is 2 rho LB upon area is pi into 4R square. This will be 2 rho LB 4 square, it is 16 pi R square, which is equal to rho LB upon 8 pi R square. In both the cases, R is same, right? So this means rho LA by 4 pi R square is equal to rho LB 8 pi R square. Rho, this is 4, this will be 2 pi R square, pi R square. So LA is equal to LB by 2. LA is equal to LB by 2. So LB by LA is equal to 2 by 1. LB by LA is equal to 2 by 1. Option C, yes. Just apply the fundamental formula. R is equal to rho L by A. That's all, right? So read the questions and put the appropriate data. The two wires of same material have length L and cross section R 4A and A. L and A, next material L into 4A. The ratio of their specific resistances. Ratio of specific resistance. Let it be rho 1, let it be rho 2. This ratio would be what? Right. Two wires of same material. Read the question well. Two wires, but the material is same. So rho will not be changed. It is material dependent. 1:2, 8:1, 1:8, 1:1. Rho is equal to rho. The resistance of a wire is R. If it is melted and stretched to n times, right, the length is made as n times more. Its original length, the new resistance will be what? Right? So R is equal to rho L by A. Now R dash is in question. Rho won't change. N times you are stretching the length. R dash is equal to L dash by A dash. This is N into L dash is equal to N times it is increasing. If it is 5 meter, N into 5, right? That much amount, the A will be discussed. Already we have discussed. If it is 2L, then the area has to be decreased. A by 2. Then only L, 2L into A by 2 will give us AL. 2 and 2 will get cancelled, right? To keep the volume constant in both the cases, right? So A dash will be A by N. So this is rho N square L by A, R dash. Rho L by A is R. So R dash is equal to N square R. Rho L by A is R. R dash is equal to N square by R. This is NR. This is R by N. This is N square R. So this is R by N square. The resistance of a wire is 20 ohms. It is so stretched that the length becomes 3 times more. Length becomes 3 times more. Then the new resistance of the wire would be almost similar question. In the earlier case, N is given, now it is 3. So R is equal to rho L by A. R dash is equal to rho is constant, L is becoming 3L. Then A must be A by 3, right? So this will be rho into 9L rho L by A. R dash is equal to 9 into R. Rho L by A is R. Original value. R is equal to 20 ohms. So 9 into 20, 180 ohm is the answer. 6.67. Option D is right. The resistance of a wire is 2 ohms. If it is drawn such a way that it experiences a longitudinal strain, 200%. Its new resistance, how much? Strain formula, longitudinal strain, delta L by L. Original length, what is the change? Only the change. How much you are stretching? It is 10 centimeter. I am stretching it to 11 centimeter. The delta L is 1 centimeter, right? This is 200%. So if it is 1 meter, then another 2 meters are coming. You are stretching that. This is already it is 1 meter. Assume you are stretching it at 200%. The delta L is now 2 times more, right? That is the meaning of longitudinal strain. Delta L by L is 200%. Or delta L is equal to 2L. Only the change is 2L, not the entire length. Entire length L plus delta L. Right. So the new L is L plus delta L. Delta L is 2L. 3L. 3 times they are stretching, that's all. 3 times stretching. Now we can easily solve it. R is equal to rho L by A. R dash is equal to rho L dash by A dash. L dash 3L. A dash 3 times it is more. So A by 3. So 9 rho L by A. R dash. Originally it is 2 ohms. So 9 into 2, 18 ohm is the answer. New value is 18 ohms. 8, 16, 18. The resistance of a wire is 20 ohms. R is equal to 20 ohm. It is so stretched that the length becomes 3 times. Then the new resistance will be length becomes 3 times more. Easily we can do it, right? So R is equal to rho L by A. R dash is equal to rho 3L by A by 3. L dash by A dash. So 9R. R is 20. 9 into 20, 180 ohms. 180 ohms, option D. The specific resistance of the material of a wire is rho. Okay. And its volume is 3 meter cube. Its resistance is 3. The length of the wire will be, length is in question. Rho, the value is not given. Rho values, let it be rho. The options are in terms of rho only. In terms of rho, we will find the answer. R is equal to rho L by A. Instead of A, they have given the volume. Length is asked. Rho we can keep in the option, in the answer. L is in the question. R value is 3 ohms, but A is not available. Instead volume is available. Multiply and divide it by L, so that A will become a volume. So rho L square by AL is volume. R value is 3 ohms. Rho L square by volume is also 3. 3 into 3, 9. 9 is equal to rho L square. So L square is equal to 9 by rho. L is equal to 3 by root rho. This is the answer. Simple. 1 by root rho, 3 by root rho. Yes, option B. In option B, our right answer lies. If a wire is stretched to make it 0.2% longer, 0.2% longer. In terms of percentage, they are giving. Actual length not given, percentage. Its resistance will be R dash, how much? New value. Just a 0.2%, any length you can take. 0.2% they are stretching it, right? So change in resistance, it is the new value is, the new length is 0.2% more than the previous length. So R is equal to rho L by A. If L is increased by some factor, the same factor the area is going to decrease. Rho L square by volume, isn't it? Multiply and divide by the length, as we did in the previous problem. L into L square, A into L, volume. Now volume constant. If you stretch it, volume doesn't change. Right? Now rho and V are constant. R. That means R is proportional to L square. R is proportional to L square. Stretch it to make it is 0.2%, right? The change in R by R. Method of error analysis, we can do it, is equal to 2 into change in length by length. The delta R by R is equal to 2 into differentiation, 2 into delta L by L, by method of analysis. In class 11, in the units and measurements, in the first chapter, we have solved, we have seen many problems. So delta R by R is equal to 2 into delta L by L. This is 0.2%, stretch it to make it 0.2% longer. So 2 into 0.2%. So the answer is 0.4%. Change in resistance. Change in resistance. If you stretch it, change increases by 0.4%. Yes, If R is stretched, definitely the value will be increases. Length and R are directly proportional. Decreases by 0.4% wrong. This is 0.2%. Yes. When a wire is stretched so that its radius is increased by 1%. Radius increased by 1%. What is the percentage change in R? R is radius and negative sign indicates decrease in resistance. In the option there is a negative sign. So they are specifically telling that the negative sign indicates decreasing. In the previous problem, it was in terms of words. Increases, decreases, increases, decreases. So in this problem, they are saying this is decreasing, this is increasing, this is increasing, and this is increasing. Right? So in the same method we can solve. Or rho L by A. L they are not changing. Radius they are changing. Radius they are changing. Increased by 1%. R value is changed. So length must be reduced. Right? So rho L by A. R is directly affecting area only. Cross-sectional area is now pi r square. R directly comes into the formula area. So area is equal to pi r square. So I have to keep the length and length, yes, L square by A into L. This way I have to write. To keep the volume constant. No. We have to multiply it with area and area, not L and L. Yes. So this problem is different. L into A by A into A. L into A by A into A. Rho. So because they are changing the radius in turn changes the area. So I want to find the relationship between radius and A. So I want to keep the volume constant. That is why I am writing L into A. Now this is V, this is A square. Rho and V are now constant. Right? In this previous problem, we changed the length. But here, we want to keep the area here. So that I am getting one relationship between R and A. Right? So now R is inversely proportional to A square. Rho and V now I kept constant. So in the previous problems, we kept volume in the denominator. Now the volume, we are keeping it in the numerator, right? Because we want to keep the radius is changed, right? R is directly proportional to 1 by A square. But A is not given, instead radius is given, right? Again the method of analysis, dr by R is equal to, this is A power minus 2, R proportional to A power minus 2. A power minus 2. So dr by R is equal to minus 2 into dA by A. By method of analysis, method of error analysis, right? Radius we have to incorporate it. Area is equal to pi r square. Area is proportional to r square. Again I will write dA by A, error analysis, is equal to 2 times dr by r. 2 times dr by r. Instead of dA by A, I can take this value. So this will be minus 2 into 2 into dr by r. So this is minus 4 dr by r. The change in resistance is minus 4 dr by r. Minus 4 dr by r. Option A, it is decreasing. The resistance value, change in resistance value is decreasing. Right? A uniform wire made up of copper is stretched though so that its length increases by 10%. Increases by 10%. The percentage increase in resistance is length increases by 10%. If it is 1 meter, now it is 1.1 meter. If it is 1 meter length, then the new value is 1.1. Length increases, right? So R is equal to rho L by A. R dash is equal to rho L dash by A dash. R dash is equal to rho L dash is 1.1 L. L by A dash will become A by 1.1, the same value. So this is 1.21 rho L by A, which is equal to 1.21 R. R dash is equal to 1.21 R. The change in value in terms of percentage they are asking. So, delta R by R is equal to 1.21 R minus R divided by R. So this is 1 R 0.21 into 100. So this is 21%. Option D. Yes. Why can't we solve this problem by method of error analysis? In the previous two problems, delta R by R, method of error analysis only 0.2%, we have solved it. In the next problem also, 1% by method of error analysis we have solved it. But if we solve this problem by method of error analysis, let us find how much the answer is coming. dr by R, actually R is equal to rho L by A. R is proportional to L square, isn't it? L square, L by L, AL, volume become constant, rho and V will become constant. R is directly proportional to L square. So dr by R is equal to 2 times dl by L. dl by L, length is stretched by 10%. So this is 2 into 10%. The answer will be 20%. 20% is wrong. 21 is the accurate answer. 20% wrong answer. Then which method we can adopt? The previous two problems we have solved by error analysis method, but this problem we are solving by the traditional method from the fundamental. We are not adopting that method. Why? Yes. The error is more than 5%. If it is more than 5%, don't go for error analysis method. 10%, so only up to 5% we can do it. In the previous problem, it is 1%, less than 5. Before it, 0.2%. So they are low values. That is why I have used error analysis method in the previous two problems. 0.2%, okay, it is less than 5. Then 1% less than 5. But here it is 10%. So if it is more than 5%, you go for the traditional value, right? Traditional formula and that method. A conducting wire of length L, radius of cross section R and resistance R. L, small r, This is resistance, radius, and this is resistance. Stretched such that its radius becomes r by 2. Its new resistance is what? Or rho L by A. So radius directly affects the area. A is equal to pi r square rho L by pi r square. In this case, r dash is equal to rho L dash by A dash. Area pi into A dash. Pi into r is becoming r by 2 square. So this is pi r square by 4. If area is decreased by the number 4, the length has to increase. 4L. Area is decreased. The same amount, the length has increased. So it is 16, 4 into 4, rho L divided by pi r square. Rho L by pi r square is r. So r dash is equal to 16r is the answer. 8r, 4r, 16r. Option C. When a piece of aluminum wire of finite length is drawn through a series of dies to reduce its diameter to half its original value. This diameter is reduced to half of its original value. Its resistance will become, what will happen to R dash? So instead of R, they are giving D. So this will be, let me write it as 2R. Then D by 2 will be R. So let it be A1. A1 is equal to pi into 2R square. 4 pi R square. A1. A2 pi into R square. Length it is L. A1 is 4 pi R square. Its length is L. Then area is becoming pi R square. That means 4 times it is decreasing. It is 4 pi R square. It is just pi R square. The new area is decreased. That means the new length has to increase. Right? Then we will have 4L into 4 pi R square. We will have the volume constant. 4 pi R square into L. 4 pi R square into L. Right? So it is 4 pi R square. It is decreasing. So I am increasing the length. Right? This is A2. L1 is L. L2 is 4L. Same material. So rho value will not change. R is equal to, in fact, R1. Rho L1 by A1. Rho L1 is L. A1 is 4 pi R square. R2 rho L2 is, let me write L2 and A2, yes, rho L2 is 4L, A2 is pi R square. R2 is in question, rho L by 4 pi square. R1 by R2, take the ratio, rho L by 4 pi R square multiplied by pi R square divided by 4 rho L. So pi r square will get cancelled. Rho L. So this will be 1 by 16. So R2 is equal to 16 R1. R1 is the original value, R2 is the new value. 16 times it is increasing. 2 times, 4 times, 8 times, 16 times. The masses of the 3 wires of copper are in the ratio 1:3:5. Masses one is to 3:5. Material shape and the lengths are in the ratio 5:3:1. Then the ratio of electric resistance what is the ratio? Since length is varying, the mass is varying, right? Masses 1:3:5, the length 5:3:1. Material same. Resistance what? Resistance R is equal to rho L by A. Rho in all the 3 cases it is going to be constant. Same material copper. L the value is available. Instead of A, mass is available. We have to connect mass and A here. If you do it, the problem is over. Right? For the given material, density have the connection between the volume. Right? Density. Volume we can easily bring here instead of A. Right? So volume is equal to mass upon density. V is equal to m by d. Mass upon density. V is equal to A into L. A into L. I need A m upon dl. This is taken for substitution here. So now R is equal to rho L upon m divided by dl. This will be rho L square d by m. R is equal to rho L square d by m. Density constant for copper, kilogram per meter cube. So rho constant. So R is proportional to L square by m. L and m are available. L and m are available. You can easily find the ratios, right? So R1 is to R2 is to R3 is equal to L1 square by m1. Similarly, L2 square by m2, L3 square by m3. L1 5 square, that is 25 by m1 1. 3 square by m2 is 3. 1 square m3 is 5, 25. So this will be 25 is to 3. 3 square by 3 is 3. Then 1 by 25. L3 is 1, this is 5, yes. M3 is not 25, right? It is only the numerator is square, yes. So it is 5 only. So this 5 into 25, 125, it is 15, then this is 1. This is the answer. Option D. We need area, mass is available, density, it is always constant. From density we are bringing the volume, from volume we are making the area. Specific conductance of a conductor is sigma. Conductance, not resistance, it is. Specific resistance. Specific resistance is rho, but here it is conductance is given, sigma. If the change of the electron is doubled, charge of the electron is doubled. Without changing the mass and charge density, mass constant, charge density, electron density. This means electron density, free electron density. N is also constant. Then the new specific conductance is what? See, rho is equal to 1 by sigma. Rho is equal to 1 by sigma. Rho is equal to m upon n e square tau. Then sigma will be n e square tau by m. Reciprocal. Sigma. N we have not changed. N is constant. M, mass is also constant. Always we keep the temperature constant, so tau is also constant. So sigma is proportional to E square. Charge, it is doubled. So this will be, the new value will be sigma dash is proportional to 2E square. Sigma is proportional to E square, that is the general formula. The new sigma is double the value of charge. Then sigma by sigma dash is equal to E square by 4E square. So this will be sigma by sigma dash is equal to 1 by 4. Sigma dash is equal to 4 sigma. 2 sigma, sigma by 2, sigma by 4 sigma. Yes, that's all. So we have come to the end of this video lecture. Just the fundamental formula R is equal to rho L by A. Then rho is equal to 1 by sigma. J is equal to sigma E. E is equal to V by L. Then method of error analysis. So these are the things I have used to solve few examples under the topic specific resistivity and resistance. So the origin from drift to velocity we have come here. From drift to velocity we derived the equation for resistance. From resistance we have found what is specific resistance or resistivity, right? So this is the end of our video lecture. Thank you for watching. Good luck.